Hey guys, Mr. Gibson here. I'm going to take you guys through a micro FRQ. Um, anyway, there's two questions on this one from 2017 that I want to go over. Let's go ahead and start on this one. Number one, the first question is always usually a firm question. You'll have a perfectly competitive firm or maybe a monopoly. Less often you'll see a monopolistic competition. But anyway, it's you have to look at firm structure and talk about that. So in this case, we have a corn is used as a food and as an input in the production of ethanol and alternative fuel. Assume corn is produced in a perfectly competitive market. Okay, so what I'm going to do is I'm going to go through this problem. Um, I will. I'm not going to write everything down. I just think that would take a little too much time when I tried this before. Um, anyway, uh, but I will kind of show you guys some graphs. I know you guys won't have to use graphs on this test, but it's going to be helpful to sketch some graphs. So I think this will help you guys illuminate some of these ideas. We'll go over the scoring guidelines, and you can see what should be written down in those scoring guidelines. And of course, you can find this on the internet too on the AP website if you just search AP FRQs microeconomics, and you can go year by year. So anyway, let's go ahead and get on this and talk about it. So it says first A, draw a correctly labeled side-by-side graph for the corn market and the representative corn farmer on your graph. So each of the following. So this is going to be the important part here. I'm certain there'll be questions about firm graphs. Okay, in this case we have a perfectly competitive farmer, and we've got a equilibrium price and quantity in the corn market, P sub M, Q sub N, respectively. Okay, so we're gonna have a side by side graph. There we go. Um, so first, let's go ahead and do our market quantity, price, downward sloping demand, upward sloping supply. Here's our equilibrium, P sub M, Q sub M. Okay, so there's our market. All right. Says then profit maximizing quantity of the corn produced by the respective representative farmer earning zero economic profit labored Q sub F. So this is what we mean by a side by side graph. Here's our second graph. This is for the farmer. Okay, he has his quantity. You can put a price right here, but it's a price. It's just a dollar amount. And here's the important part: the corn farmer is a price taker. So this price in the market is going to be the price that he takes. It's going to be the demand for his product. And it's also, or his personal demand for the product. And it's going to be his marginal revenue. Okay. It's also his average revenue. Okay. So we need a profit maximizing point for this corn farmer. So let me draw a marginal cost curve. Not the straightest curve, but it'll suffice. Okay. And this is Q sub F because this is the quantity that the farmer's producing himself. Okay. Now, the key here too is this is often enough for us, but in this case, they do want us to illustrate that he is a um, earning zero economic profit. So I also need to draw an average total cost curve like this to show that the average total cost curve is intersecting right here at this point where he at his profit maximizing point. Okay, so price, uh, his average total cost are equal. He's earning zero economic profit. Okay. All right. Assume the demand for ethanol increases. On your graphs in part A, show what will happen to each of the following in the short run. The market price and quantity of corn labeled P star and Q star, and then the area of economic uh, profit or loss earned by the representative corn farmer shaded completely. Now, you guys might be looking at me and it's like, man, Mr. Gibson, that's a lot of graphing. Okay. They're not going to get us to graph on this test, but I'm telling you guys, it's going to be useful because they're going to ask you these same questions, but they're not going to let you graph it. They're not going to give you points to the graph. That's why I told you guys earlier this month that, hey, y'all might be celebrating this no graphing thing, but it's really going to make it actually a little harder. So please, please take my advice just to sketch a little graph like this. Won't take you guys long to be able to answer their questions. Okay. So anyway, what do we have? A price of ethanol, which is an input. Corn is an input. Because it's an input, that means that the demand for ethanol will go up. As the demand goes up, it means the price is increasing. And this farmer here now has this price and this marginal revenue. Okay. Alrighty. Uh, so we want this area of profit because it'll be a profit now because look, his price is right here. His marginal revenue is right here. This is the profit maximizing point. So this will be Q. Oh, I forgot to do my Q star and my P star. Again, that won't matter on this test for you guys since they won't actually make you guys label it, but it'll help us with this. And that means his ATC is right here. So if I just go ahead and shade this area in there, that will represent his price higher than his ATC. That represents his profit. Okay. Shaded completely. Which, yeah, I don't have to worry about that. So I'd be shading it completely. So there's no doubt. Anyway. All right, great. So C, I feel like on this test, you guys, because there's so little time, there's no graphs to draw. These are the types of questions they're going to ask. They're going to give you a setup like A and B, where you're going to have to kind of sketch your graph by yourself, but then C is where the question's going to lie. And this is where it's important that you guys have drawn your graphs, okay? Relative to your answer in part B, state what will happen to the market equilibrium price and quantity of corn in the long run. Okay, here's what's going to happen. So he's earning economic profit. Okay, we can see that. There's free entry and exit for a perfectly competitive firm. So what's going to happen there is that means more firms are going to enter the market. And as more firms enter the market, the supply for corn is going to increase. Okay. In the long run, it's going to increase all the way to where it equals where we have zero economic profit, where ATC equals marginal revenue, but we don't even have to consider that in this problem. So, but what we can consider is, look, as supply increases, the quantity increases, and the price goes back down. Okay, quick sketch. All right, so relative to answer B, the equilibrium price increase or decreases, and the equilibrium quantity increases in the long run. And the explanation is because there is free entry and exit in a perfectly competitive market, because farmers are now seeing economic profits. More firms will now enter the corn market, which will make the supply for corn increase. And as the supply increases, of course, equilibrium price will go down and equilibrium quantity will increase. Okay, there you go. All right, D. Soybeans are produced in a perfectly competitive market. Assume farmers can grow either corn or soybeans on the same land. So that means that they're production substitutes. What happens to the price of soybeans in the next planting season if the price of corn increases? Explain. Okay. So again, this is where I want to kind of sketch a little graph. So I'm thinking to myself, okay, let's look at the soybean market, quantity, price, real quick graph. And I start going, okay, there's substitutes in production. And if the price of corn goes up, okay, if we anticipate, if uh, so if the price of corn goes up, that's going to make farmers want to plant corn, okay, which means they're going to have to use their land to plant corn, which means as they use their land to plant corn, they use less their land to plant soybeans. And if they use less their land to plant soybeans, the supply of soybeans decreases. And as you guys can see, the quantity of soybeans decreases, but the price of soybeans increases. Okay. So I sketched a graph and I pretty much did the explanation there, right? It means there's substitutes in production. Uh, the farmer decides to use his land to farmers decide to use their land to plant corn instead of soybeans. Supply of soybeans decreases, price increases, quantity of soybeans decreases. Okay, and it just asks for the price of soybeans, so the price of soybeans will increase. Okay, assume instead the government sets a binding price ceiling in the corn market. Draw a newly correctly labeled graph for the corn market and show each of the following: the binding price ceiling labeled price C, and the quantity purchased by consumers in the corn market labeled Q sub P. All right, so let's go ahead with that. Okay, kind of a random question. This would be kind of an easy question for the end of this. Okay. Again, you won't have to draw graphs, but it's going to ask you questions that you're probably going to have to use a quick sketch of a graph. And I'm sure you guys are sick of me saying that, but it's true. Okay. Now, binding price ceiling. A ceiling means I can't go higher than a ceiling. And if it's binding, then that means my equilibrium price is above the ceiling. Okay. I can't get to my equilibrium price, it's too high. Okay. So that means that there's been a price set somewhere down here below the equilibrium. Well, sure, people are going to demand more right here, but all that's going to be supplied is right here. So this is actually going to be our Q, what did they say? Q sub P, okay, is right there. And of course, there'll be a shortage. There'll be a shortage in this case, all right? And this right here represents our shortage, okay? So um, even though Q sub P, we get that from the supply curve. That's the actual quantity that's going to be purchased by consumers because that's all that's left in the market. All these other consumers out here, over here, they're out of luck. They just can't purchase it for that price. Okay. All righty. Move on to number 2. The table below shows the output a firm produces using different amounts of capital, K, and labor, L. The markets for capital and labor are perfectly competitive. The rental rate of capital is $75 per unit, and the wage rate is $200 per unit. In the short run, capital is fixed and labor is variable. Okay, so I just messed with my thing on by accident. So K is capital, L is labor. Capital costs $75 per unit. Labor cost $200 per unit. Okay. Now, if you look at this table, let's just be very clear. Okay. Um, capital is fixed. Either you can have a capital of 1 or a capital of 2. So we want to see what we can make when we have a capital of 1. Okay, so this column right here says, okay, capital is 1. We hire labor. How much can be produced with this capital? Okay. We've got capital of 2. Again, that's fixed, but there's more capital for these laborers to use. So here's how much you can make if the capital is 2 and how much you can make with each piece of labor. All right. So again, of course, when there's more capital, uh, labor is more productive. That's basically what this is showing. So you kind of have to just be able to make a delineation between the two. Okay. This is here for this. Okay. And then this is here with this. Okay. It's almost like it's 2 separate tables that they put in one. Okay. Not a great table, but we're going to live with it. All right. So, question 1. If the firm uses 1 unit of capital and 1 unit of labor, so We're right here. Okay. Will it be operating with constant, increasing, or decreasing returns to scale? Explain using numbers from the table. Okay. So if we are using, let me see. So if we're using labor, if I double this labor, okay, from 1 to 2, so it doubles times 2. Well, I'll more than double, okay, greater than times 2 with output, okay. So if it were constant, I would expect that this second piece of labor would um, produce 20, okay. If it was uh, if it was decreasing returns to scale, it would be less than 20, but this is increasing returns to scale because it's greater than 20. Okay. Um, so yeah, that's basic with that. That's what you could explain. You could also do it with some average total cost. Um, the average total cost right here. Okay, one piece of capital, so it's about 275. Okay, is the cost here per unit. We produce 10. So it'd be about 275 when we're producing right there. If we move to 25, okay, that's two pieces of labor. So two pieces of labor is 400. So it'd be 475 divided by 25. Okay. So what that's oh Lord, that'd be so 25 into 100 is 4. 4 times 4 is 16. Uh, 75 is 3. So would that be 19? Right, goes into 19. Okay, so you get 19. Um, yeah, I think I just confused myself with that. Let me check the answers real quick. Should be going down. I think I did something a little wrong. Let's just check it with each other. Explain the average total cost decreases from. Oh. Oh, it's because I did my math wrong in the first part. Duh. All right, let's see. That's where I confused myself. That's $27.50. Not 275. So this is $27. 27.50. Okay, duh. And this one, where are we getting 11? Be careful real quick. We're done. Oh, this says labor and so if they both double, we get to 50, and we're no longer at this. And maybe I need to backtrack real quick. That's okay. But if we double both, so double our inputs, we um, we quintuple our outputs. So that goes back to that claim too, that if we doubled our outputs, so we double the labor, double the capital from 10 to 50. We'd expect it just to be 20, but it's 50. That's quintupled instead of doubled. So again, if it were less than 20, it would be decreasing returns to scale. If it was 20, it was constant returns to scale. But it's 50. It's increasing returns to scale. We went from an average total cost of 27.50 that I showed right there. Um, capital will be $150, 75 times 2, and this will be 400. So we got 550. divided by 50. Yep, it's $11. Okay, sorry about that. The one thing I got confused is that if we're going to look for increasing returns to scale or decreasing returns to scale, that means you got to double all outputs. So if we doubled all outputs and got to 20, that would be constant returns to scale. If it were less than 20, decreasing returns to scale. But in this case, it quintupled. It went from 10 to 50. Then, of course, we've got increasing returns to scale. Okay. I showed it with average total cost as well. Our average total cost went from $27.50 to $11 uh, per output. And that shows us that uh, our costs are going down. So if that's increasing returns to scale, if your average total cost is going down. Okay, great. B, assume now that the firm currently has uh, assume that the firm, okay, has 2 units of capital and is using 3 units of labor. Okay, so we are down here. Should be producing 25. Calculate the marginal product for the third unit of labor. Well, that goes from 75 minus 50, 3 minus 2, or the rate of change is just 25. Okay, so that's the marginal product of that labor, the uh, third unit. Okay. Um, did the firm experience diminishing marginal returns with the addition of a third unit of labor? The answer is yes, and you can tell that because look, we went from the second unit of labor, uh, an increased output by 30. Our third unit of labor only increased it by 25, so that's diminishing returns. Calculate the firm's average total cost for its current level of production. Show your work. Okay. So we've got a $150 in capital and $600 in labor. That means we have $750. Okay. The average cost per unit would be 750 divided by 75. So that looks like it's going to be $10 per unit. Okay. If the firm's output is sold in a competitive market, what is the lowest output price at which the third unit of labor would be hired? Okay. So, losing my train of thought. Sorry. Okay. So the third unit of labor adds 25. Let me do a new color up here. Okay. So they produce 25. Okay. They cost $200 per unit, okay, and produce 25 units. So they would have to be 200 divided by 25 equals $8. So they need to be giving you at least $8 per per unit, okay, because they are contributing they cost $8 per unit, so you can need to get at least back $8 per unit, and you don't have to explain that. Okay, you don't have to explain that. Okay. All right, let's look at some answers here real quick. Probably should have done this right after the first FRQ, but we're backtracking a little bit. There's our market. You can see the demand increasing because the ethanol price is going up. Shows the demand going up in the firm, the shaded region of the profit. Okay, making sure the ATC hits the marginal marginal cost and the marginal revenue and demand right there at this point right here. Okay, all right, because that is the zero economic profit point. Okay. 1 point is earned for showing the rightward shift of the demand curve and the higher price. Okay, that's what we just showed. 1 point is earned for saying that the market quantity will increase, the market's price will decrease in the long run. Saying that the new corn farmers will enter the market, which will increase the market supply. We explained that. D, 1 point is earned for saying that the price of soybeans in the next planting season will increase. Okay, we showed that up here. Okay. And we also explained, for explaining the supply of soybeans will decrease, causing because the higher price in corn encourages farmers to substitute corn for soybeans in production. I probably didn't emphasize that word enough. Maybe I did. There are substitutes in production. Okay, so you can either choose to plant corn in this patch of land or soybeans in that patch of land. So they're substitutes. Okay. We drew this graph. P sub C is your equilibrium price. It's a binding price ceiling. Okay. And it intersects the supply curve because that's all that's going to be produced. So that's all that consumers can actually consumers can actually purchase. All right. Let's see. Uh, we talked about this. 1 point is earned for saying that the firm will be operating with increasing returns to scale, doubled its inputs, so output and input, doubled both capital and labor. It increased from 10 to 50. Um, so make sure you double both capital and labor to illustrate this. And rather than the units doubling to 20, they quintupled to 50. So that's increasing returns to scale. And also showed that the price, the average total cost, the cost per unit of being produced went from $27.50 to $11. Okay. Calculate the marginal product, real simple. Talked about diminishing returns. The second unit of labor was 30 units. The third unit of labor was 25. And then we showed average total cost by just quickly calculating $10. And we talked about the lowest output price being $8 because the third unit of labor costs $200 and produces 25 more units. That's $25. That's $8 per unit, which means yes, you got to at least get $8 per unit back in revenue to justify hiring that third guy. Okay. Thanks for your attention.